Hello, students. I hope that you will be fine there. As agreed that this week's session I'll record myself and I'll upload the recording of my lecture. So today's session is basically on the binder jetting process. You're aware that we have already discussed that if we go quickly over the different branches of additive manufacturing, there are 7 big classes. We are aware we have seen these branches before in the previous sessions as well. And today, for example, we are going for this next session for us. So if you remember, we have taken the wet polymerization, we have taken material extrusion, powder bed fusion. In the last session, we discussed material jetting. Now we are looking into this technology, which is referred as the binder jetting process. So our today's session will be based on that, and we'll discuss the different insights related to that. So that is the main thing, a brief overview. You are aware that American Society of Testing Materials, they are working into this area. And at the same time, the dedicated committee that is looking into it, it is called F42. This is technically developing the standardization for the additive manufacturing process. So we'll be discussing this process of binder jetting today in detail. If students, we go ahead and we try to let me erase from here. Yes. So if we talk about, for example, the basic definition of binder jetting, this is an additive manufacturing process in which an industrial print head selectively deposits a liquid binding agent onto the thin layer of powder particles. Foundry, sand, ceramic, metals, composites, and these are in fact, the materials that can be binded together to build a high value and one of the kind parts and toolings. This is called as binder jetting process. What you understand how it would be different from the previous processes, definitely here in this case, the material that you need to bind is available in the form of powder. So it's like kind of powder bed system, you can say that. However, instead of a laser or instead of electron beam, there is a print head that is ejecting the binder, and binder is also available in the form of liquid. So binder is liquid and the material is present in the form of powder. The process combines these two together and selectively binds the material. As a result of this thing, once you bind layer by layer, you can end up constructing the 3D object out of it, right? This is similar to the printing on the sheets of paper. The process is repeated layer by layer using a map from the digital design file. And so this is very similar to printing on a sheet of paper process if it's a 2D. But the idea is that the material is in the powder form and the binder comes in the form of liquid, selectively binds the material layer by layer and builds 3D geometry out of it. So that's the main idea in this. Now, if we go further, so here again we have uh, this is the material taken from the textbook. So binder jetting methods were developed early in 1990s. Mainly it was developed at MIT. They developed what they call the 3D printing or 3DP process, in which a binder is printed onto the powder bed to form the part cross sections. This concept can be compared to the powder bed fusion system, as I have told you, where the laser melts the powder particles to define the part cross section. You're aware we have taken a complete session on powder bed systems. The wide range of polymer, composite, metal, ceramic materials have been demonstrated by only the subset of these. These are the commercially available. Some binder jet technology machine contains nozzles that print color, enable the fabrication of parts with many colors. So this is also an important trait of the process. Several companies license the 3D printing process technology, 3DP process from the MIT, and became successful machines developer, including X1Z Corporation, for example, that was later on purchased by 3D Systems in 2011. So that's a brief introduction about that, how the technology got evolved. And for example, what are the different players? So these are the different players which are generally working in this technology or making machines out of it. Then students, if we go forward, we in the next slide, this is kind of looking into the process itself. So the binder jetting process uses two materials, as I told you earlier in my previous explanation. It is technically a powder-based material, and then it is a binder. So binder acts as an adhesive between the powder layers, right? And the binder is usually in the liquid form, right? Binder is generally in the liquid form. In next slide, I'll show you some of the names as well, that what are the materials which are being used as a binders, and the build material is technically in the powder form. The print head moves horizontally along the X and Y axis of the machine and deposits alternating layers of the build material and the binding material. After each layer, the object being printed is lowered onto the build platform. Due to the method of binding, the material characteristics are not always suitable for the structural parts. And despite the relative speed of the printing process, additional post-processing can add significant time and the overall to the overall process as well. This is technically how it looks like for the time being. And